Okay, more stereochemistry. Sometimes I feel like we just spend so much time talking about stereochemistry, but we're almost there. Two videos left, this one and the next one, and I think we'll be there. So this one is going to be about meso compounds. Meso compounds are different, are a diastereomer, a specific type of diastereomer that has a very um, surprising, unexpected property in that it doesn't have an enantiomer. And so we're going to go through and talk about it. Meso compounds are actually really easy to spot once you know what to look for, but we need to talk about what to look for before we can get to the point that we call them easy. So we'll do that, and then we'll jump on to the last video of the week. All right, so meso compounds. Meso compounds are, let's see, what are meso compounds? Hey, come back. Meso compounds are compounds that satisfy two criteria. Compounds with more than one, oops, more than one stereocenter that have a plane of symmetry. All right, so an example of a meso compound. Let's do this compound. Right? This compound has two stereocenters. It has one here and one here. Right? Each of those is an sp3 carbon. Each of them has four different groups attached. It has a bromine, a hydrogen, a methyl group, and then it has the rest of the molecule attached on the other side. Right? So you can go through and convince yourself that there's two stereocenters in here. What I want to draw your attention to is the fact that there is a plane of symmetry. So if you put a mirror right through the middle of this molecule and reflected everything on the left over to everything on the right, the two sides of this mirror image are identical to each other, right? So this is a meso compound because it satisfies the criteria. It has more than one stereocenter and it has a plane of symmetry. Now, what's interesting about meso compounds, as I said at the beginning, is that meso compounds do not have an enantiomer. So they are a compound that has a stereocenter but doesn't have an enantiomer. Right? So this is kind of this weird exception to the relationship between stereocenters and enantiomers. So if we draw the mirror image of this compound, or let's say that we'll do the other trick. So if we have multiple stereocenters and we want to draw the enantiomer, right, we can just switch the wedges and the dashes at all the stereocenters and we should get the enantiomer. So we do this and we get this compound. And it turns out that this is identical to the original. Right? And if you think about it, if you pick this compound up and just flip it over 180 degrees, then this would be, take your compound, the bromines that are pointed back away from you, right? So you got two bromines pointed back away from you. If you flip it over, those bromines are going to be coming out of the board at you, and that's going to be your original compound, right? And because you have just the same thing on each side, you have that methyl group on each side. When we flip it over, those methyl groups line up perfectly with the methyl group on the other side. So these two compounds are the same, which means that the mirror image of a meso compound or the enantiomer of a meso compound is the same compound. So meso compounds do not have an enantiomer. The fact that they have a mirror plane of symmetry right through here is enough to kind of destroy the rule that compounds with stereocenters have enantiomers. Meso compounds are really easy to spot because they almost always look like this. They look symmetric, right? They have the same groups on both sides. You have the same whatever heteroatoms you might have on one side, you have to have on the other, right? So spotting a meso compound is very straightforward. Realizing what that means, and that's this bit down here. This is the important bit. If I can find my ridiculous, right? This is the important bit. Meso compounds do not have any enantiomer. This is the outcome of finding a meso compound. So when you see compounds and you're asked if a compound is meso or to find meso compounds, look for that mirror plane. You're looking for that symmetry. Meso compounds will always have more than one stereocenter because you have to reflect a stereocenter on one side onto the other side, and they will always have a plane of symmetry. So they'll always actually have an even number of stereocenters because anything on the right side has to reflect onto the left. And that's meso compounds. Like I said, not that difficult. Finding that plane of symmetry is the big one. Look for those symmetric molecules and then just double check that everything reflects from one side to the other, and you've got it. All right. Next up is naming one specific kind of diastereomer. We'll get to that. This is double bonds. That's the last video of the week, and then we are ready for exam number 2.